Hey, algebra students. In this lesson, we are going to be talking about solving inequalities that have variables on both sides. And I think you're going to find this to be a pretty easy lesson as long as you have understood the algebra that we've been doing this year and how if you do one thing to one side of an equation, you have to do the exact same thing to the other side of the equation. This is exactly like that. This is like solving equations with variables on both sides, with the one added thing that we're dealing with inequalities. So we need to make sure we keep track of the direction of the sign, especially when we're dividing or multiplying both sides by a negative. But nothing changes in that regard either. So the only time we ever flip the inequality sign is if we multiply or divide both sides by a negative. Okay. Now, the one confusing thing, if you look at letter A, is when we have variables on both sides, I still sometimes at this point of the year see students who will try to divide both sides by something instead of doing the correct thing. Okay, look at letter A. How do you get x on one side of the equation? Well, I notice it's on both sides. I notice on the right side we have a minus 2x. Well, the thing you need to do in a case like this is add 2x to both sides. So we have 4x minus 8 is greater than negative 2x plus 4. I'm just going to add 2x to both sides, and that's going to get rid of it off the right-hand side, plus 2x. So we're going to have 6x minus 8 is greater than 4. Notice now I have x on one side. So the first step is to get my variable term on just one side of the equation. Now I'm going to solve my variable term like I always do. I'm going to add 8 to both sides to get my x term by itself. That's going to give me 6x is greater than 12. And now I can divide both sides by 6. And that's going to get the actual x variable by itself. This is going to be x is greater than 2. All right, let's plug in 2 and just make sure that that's correct. So if I plug in 2 on this side, I get 0. I plug in 2 on this side, I get 0. So 0 equals 0. It's not greater than 0. But now this says that x has to be greater than 2 for it to be a solution, so I wouldn't expect 2 to work. Let's try plugging in 3. 3 is greater than 2. Does that make this a true statement? 4 times 3 is 12, minus 8 is 4. Negative 2 times 3 is negative 6, plus 4 is negative 2. So 3 works as a solution because 4 is greater than negative 2. So this checks out as being a solution to this problem. Let's just see if we did it right. Here's the answer, and then we need to graph our answer in these problems as well. So for letter A, our graph looks like this. Notice that 2 is a empty circle, and then I shade everything to the right of it. All right, let's take a look at letter B. Now, for letter B, I'm never going to write this out in its complicated form because there's an easier form for this problem. And that is, let's multiply everything by the least common multiple of the denominators. In other words, I'm going to multiply everything by 10. Okay. And when I say everything, I mean everything. Each individual term is going to get multiplied by 10. So my first term is it's negative 30a over 5. Negative 30a over 5 is negative 6a when I multiply that one by 10. Plus, multiply this next one by 10. 70 over 10 is just 7. It's greater than or equal to multiply 2a over 5 times 10. That's 20a over 5. That's going to be 4a minus, and then 90 over 10 is 9. So I just multiplied everything by 10, and that gives me this much easier to solve inequality. Okay, so the first thing I'm going to do here is add 6a to both sides. Well, that's going to give me 7 is greater than or equal to 10a minus 9. And then I'm going to add 9 to both sides. And I get 16 is greater than or equal to 10a. Now I'm going to, let's see, divide both sides by 10. So I'm going to have 16 over 10. I'm just going to simplify that right away. 16 over 10 is 8 over 5 is greater than or equal to a. I'm going to make a on the left. If I swap sides of everything, so a goes over to the left and 8/5 goes over to the right, that's going to give me a is less than or equal to 8/5. Let's see how he did on this one. Okay. 1 3/5 is the same as 8/5. So we got it. And then if I was going to graph that, it would look like this. Here's 1, here's 2. 1 3/5 is 3/5 of the way between 1 and 2. I'm going to fill in the circle because it's less than or equal to and shade everything to the left. Now, let's plug in 1 and see if we got a right answer here. And I'm not going to plug in 1 to this abomination because with all these fractions, that's going to be really hard to solve. I'm going to plug in 1 to this equivalent expression right here. So if I plug in 1, we should have a valid solution. It's in the shaded range. -6 times 1 is -6 plus 7 is 1. Should be greater than or equal to 4 minus 9, which is -5. Yes, 1 is greater than or equal to -5. It works. Letter C. In this one, we have a lot going on. Hey, I need to distribute this 4 right away, and I need to distribute this 5 right away. I'm just going to do that before I even actually start to work the problem. So I'm going to do 4x minus 4 minus 2x is less than or equal to, and then on the other side, 6 minus 5x. And let's see, this is minus 5 times 2 becomes minus 10. Okay, now the next step, I'm going to combine like terms. I have 4x minus 2x on this side. That becomes just 2x minus 4 is less than or equal to. And on this side, I'm going to have negative 5x and 6. I can combine the 6 and the minus 10 to be minus 4. This is an interesting thing. I'm going to have 2x minus 4 is less than or equal to negative 5x minus 4. I have a minus 4 on both sides. So I'm going to add 4 to both sides. This is going to be 2x is less than or equal to negative 5x. Now, I didn't have to do that step first. I could have added 5x to both sides and then added 4 to both sides. It's just, I noticed when I add 4 to both sides, how in the world am I going to make 2 times x equal to negative 5 times x? There's only one thing I can plug in for x that makes this statement true. Let's just solve this the way we always solve it. I'm going to add 5x to both sides. It gives me 7x is less than or equal to 0. Because I just added 5x on this side and there's nothing left, so it's 0. Hey, if I divide both sides by 7, what do I get for a value for x? X is less than or equal to 0. So just going back up a few steps, does it make sense when I have a number minus 4 equal to a different number minus 4? The only thing that that number could possibly be is 0, multiplied by 0, because I can't. There's no other way. Like there's no other non-zero number I can multiply 2 and negative 5 by, so that when I subtract 4 from each of them, they equal the same thing. It has to be 0. All right. If you could recognize that pattern, that might help you solve some problems a little bit faster. So x is less than or equal to 0, and then here is the graph of that. Notice that because less than or equal to, circles filled in, and we're shading to the left. Determine whether each inequality is always true, sometimes true, or never true. If it is sometimes true, identify the solution set. So here's what we're going to do. If the inequality is always true, what we're going to find is that there's going to be an infinite number of solutions. If the equation is never true, there's going to be no solution. Those are going to correspond to the statements that we've always made about equalities. Okay, so we've solved equalities that have had no solution, and we've solved equalities that have had an infinite number of solutions. Um, and then sometimes for inequalities, like the typical inequality, like these ones, are sometimes true. And it's only if you have an x value that fits in the range that's shaded on the number line, right? So let's go ahead and do letter D and see what we get. So for letter D, we have x plus 5 plus 3x is greater than 4x plus 19. All right, now let's think about this for a second. X plus 5 plus 3x, I can combine to make this 4x plus 5 is greater than 4x plus 19. Notice there's a problem. In this problem, I have 4x on both sides of the equation, of the inequality. I'm going to have to subtract 4x from both sides. What do I get? 5 is greater than 19. Now, with these ones, unlike inequality, with an equality statement, we would say there's no solution because 5 is not equal to 19. There's no solution. In this case, we would look at them and actually evaluate: is this a true statement? Is 5 greater than 19? The answer is no. So this one is never true because it works out to something that's false. Okay. Let's take a look at letter E. Same situation. Except this time we have x plus 5 is greater than. Oh, hold on. Let me make sure we get E instead of 3. X plus 5 is greater than x minus 3. X on both sides. That's kind of a problem. Let's see what happens. Subtract the x from both sides. You get 5 is greater than negative 3. Is that a true statement? Yes. And what that means is no matter what I plug in for x, this is always true. So for this one, there's no value I can plug in for x to make the inequality true. For this one, anything I plug in for x makes the inequality true. And then finally, letter F. The table shows the average number of cell phone minutes used by Ara and Lexi. So here's Ara's 4,000 for January, and then a change from January to May of 500. And then Lexi, 12,000 for January, but she's going down 500 less average change from January to May. If the trend continues, in which month will Era's average minutes be equal or to or greater than Lexi's? All right, so if her average is 4,000 and we're changing 500 per month, we're adding 500 per month. Let's just see. Average change January through May. We're going to assume that this is an average monthly change. This is going to be, we need to figure out when this is going to be equal to or greater than Lexi's 12,000 minus 500 times the number of months. How many months will have to go by before this is true? Okay, so first thing we're going to do is we're going to add 500x to both sides. That gives me 1,000x plus 4,000 is greater than or equal to, let me just make sure, greater than or equal to 12,000. Now I'm going to subtract 4,000 from both sides. 1,000x is greater than or equal to 8,000. I'm going to divide both sides by 1,000. I'm going to just note something. Notice we never divided by a negative or multiplied by a negative, so we never swapped the sign this entire lesson. And that's totally fine. That'll happen a lot of times. So we're saying that 8 months or more, then Ara's average minutes will be equal to or greater than Lexi. Let's see. September, that's 8 months away. Let's see, January, February, March, April, May, June, July, August, September is 8 months away from January. So in 8 months, I would have answered 8 months, not September. But September is 8 months away. In 8 months or more, um, Ara's average minutes will be equal to or greater than Lexi's. All right, now you know how to work these sorts of problems. You are ready to do the problems for next time.